Just like we have operations such as addition and subtraction in arithmetic, we also have operations in set theory. These help us create new sets based on how existing sets interact. The most basic and important operations are union, intersection, and difference. Each of these helps us understand how sets overlap, combine, or exclude elements. The union of two sets A and B is the set that contains all elements that are in A, or in B, or in both. It is pronounced as a union B. For example, if set A is brace 2, 4, 6, 8, close brace, and set B is brace 6, 8, 10, 12, close brace, then union B is brace 2, 4, 6, 8, 10, 12, close brace. Note that common elements like 6 and 8 are written only once. In a Venn diagram, this includes the entire shaded area covering both sets. Here are some key properties of the union operation. Commutative law: a union B is equal to B union A. Associative law: a union B, then union with C, is equal to a union with B union C. Identity law: a union the empty set equals A. Idempotent law: a union A equals a universal set law: a union the universal set equals the universal set. These rules help make union operations consistent and predictable. Now let's look at the intersection of two sets. The intersection of A and B includes only the elements that are common to both sets. We say A intersection B. If A is brace 2, 4, 6, 8, close brace, and B is brace 6, 8, 10, close brace, then A intersection B is brace 6, 8, close brace. In a Venn diagram, this is shown as the overlapping region between the two sets. Here are some useful properties of intersection. Commutative law: A intersection B is equal to B intersection A. Associative law: A intersection B, then intersection with C, is equal to A intersection with B intersection C. Identity law: A intersection the universal set equals idempotent law. A intersection A equals A. If A intersection B equals the empty set, we say A and B are disjoint sets. The difference between sets is where things get a little more specific. The difference of minus B is the set of elements that are in A but not in B. For example, if A is brace 1, 2, 3, 4, close brace, and B is brace 3, 4, 5, close brace, then A minus B is brace 1, 2, close brace, and B minus A is brace 5, close brace. Remember, a minus B is not the same as B minus A. In a Venn diagram, the difference of minus B is shown as the portion of A that does not overlap with B.